Today we're going to continue the work that we started yesterday on dividing polynomials. So to start out our notes today, without a calculator, see if you can remember how to use long division to divide 277 by 12. Once you do, see if you can remember your vocabulary. What is the divisor, the quotient, the dividend, and the remainder when you do this long division? Pause the video, try to answer this number 1, and then unpause it and I'll go through. Or if you're struggling with it and can't find your way through it, you can follow along with me. So we're going to take 12 and try to divide it into 277. Whenever we're dividing, the thing we're dividing by, so this is the thing that would be in the denominator, is called the divisor. That's what we divide by. The thing that we are dividing, what would be in the numerator, if we wrote this as like a ratio, 277 over 12, that thing is called the dividend. So to start long division, we want to divide 12 into the number over here, starting from left to right. We can't divide 12 into 2, that's too small. So we move over, and now we're trying to divide 12 into 27. And 12 can go into 27 2 times without going over. So we're going to put a 2 up here, and we're going to then subtract 24, which is 2 times 12, and leaves us with 3 coming down here in our tens place. Now 12 doesn't divide into 3, right? We already took out all the 12s we could, so now we're going to bring down our ones place, this 7 right here, and we have 37. So we want to know how many times 12 goes into 37. It goes in 3 times, and we're going to take away 36, leaving us with 1. Now there's no more numbers to bring down. We could add a decimal place and a 0 and bring that down and keep going, but we're not going to do that here. We're going to do like we did really early on in our math education and leave whatever is extra as a remainder. So we're going to call this 23 with a remainder of 1. So our quotient is 23 and our remainder is 1. And as a reminder too, what this remainder of 1 tells us is this is 23 and 1/12, because there was 1 left and we couldn't divide it by 12. So that's the part that's left over. So we're going to use that as we divide polynomials, but for right now, today, we're going to be mostly focusing on area models. Area models are what we talked about with multiplication, these boxes that we draw, and then we use it as kind of a little table that we multiply the row and column header to make what goes in the boxes. Here there's some pieces missing though. We're going to add a 36 here, otherwise this one won't be solvable. But let's go ahead and pause the video again and try to fill in this box A and B and number 3 with all the missing information. So we have 2 missing pieces in the box, and then what are the 2 terms of our binomial? Same thing here, 2 terms of the binomial, and then 2 missing boxes. So if you haven't already, pause the video, try to figure out these blanks and answer number 3. Okay, so to figure out what goes here, we know that x times something equals x squared. And if we want to figure out what unknown thing we needed to multiply, we can figure that out by division. So we're going to do x squared over x. And when we do that, we're basically subtracting exponents. We get x to the first power. So this is an x here, right? X times x makes x squared. Now that we know that one, this box here becomes available. We can use this x and 9 to fill in 9x. For this box here, we can't figure out this box yet because we don't know what goes up here. So let's figure that one out the same way we found the x. We have a 36, which is 9 times something. So to figure that out, we can do 36 over 9, and that would be 4. So we're going to put a 4 up there. meaning this last box should be a 4x. Let's skip down to number 3 now. So it says, how did we figure out what to fill in? So we wanted to know what would multiply by something to make a given number. And the opposite of multiplication, the way we figure out what we would need to multiply, is by division. For our box on B, if you didn't fill that one out before, try it now. If you did, let's go ahead and check that. So we have 10x squared divided by 5x. Okay, so we had 10x squared divided by 5x. Remember, we handle these separately. The 10 over 5, our coefficients, gives us a 2. And then the x squared over x gives us x. Now we could fill in this bottom box. Negative 1 times 2x is negative 2x. To find our other term of our second binomial, we'll do 35x divided by 5x. The x's cancel out and become 1. 35 over 5 gives us 7. So our final box will be 7 times negative 1, or just negative 7. So for 4 and 5, you're going to do basically that same process, but it doesn't have any information pre-filled. So let me look at 4 with you, and then you can try number 5. So as usual, our divisor goes on the left. We're going to put 3x over here. We did that yesterday with algebra tiles, but we put 3 separate x's. So we did x, x, x. And then for the plus 8, we drew 8 little 1 tiles. So with our area model, we can take all of that and compress it down, because these 3 x's are all the same. They all basically cause the same result as you go across. So we can collapse them into just 3x. Same thing with these 8 1s. We can collapse those into just an 8. And then let's see where to start on this table. So the best place to start is going to be with our x squared term, because we need to make this many x squareds, and we have to make them in this box right here. There's no other box we'll be able to use for x squared. So let's go ahead and fill in 6x squared, and then find out what term did we multiply to get that. I'm sure you can just do that one in your head, but let's go ahead and write it out. 6x squared over 3x. We simplify. 6 over 3 gives us 2, and x squared over x gives us x. So now we have our 6x squared term. We're going to go down to the lower left box. Now that we know the 2x and the 8, we're going to fill in 16x. Since we have that, we want to go up to our other x box. So notice that we're going from highest order to lowest. We did the x squared. Now we're taking care of the x's. So we have 16 out of the 22 that we need. So we need 6 more x's here. In order to create that 6x, we have 6x divided by 3x, which is just 2. And now for our final box, we have a 2 times an 8, which gives us 16. 16 matches exactly with the constant that we wanted to have in our trinomial here. So that means there's no remainder when we're dividing. If this 16 came out differently, which we'll see when we go to number 6, you're going to have a remainder that's left over. You're not going to have it divide evenly. Just like in the warm-up where we divided whatever it was, 277 by 12. So number 5 is going to work just like this. So go ahead and try that one, see if you can figure it out, and then pause the video, unpause it when you're ready to go over it with me. All right, so we start with our divisor. We have x and negative 6. Next step, we move on to our x squared term. We're going to put that in the box right here, which tells us that the first part of our other binomial must be x. Now that we know that, let's drop down and fill in this box that has negative 6x. That tells us that to get the rest of our x's, this negative 13, we need how many more? We need negative 7x more. So negative 6 and negative 7 will give us the negative 13 that we need. Now we can fill in the other part of our second binomial. To get x to be negative 7x, this must be a negative 7. Then our final box is negative 7 times negative 6, which is 42. We go back and check. 42 is exactly what we wanted, so we are good. Our answer is x minus 7. For number 6, this one's a little different. So it has a similar setup. We're going to go ahead and draw our boxes. We're going to put our divisor, x plus 2, and we're going to start off with 2x squared. So our multiplier that we need here, when we divide 2x squared over x, we get 2x. Our box down here then, 2x times 2, would be 4x. Since we need 7 total x's, this must be 3x. And then up here must be a 3, because 3 times x would give us this 3x. Our final box then has to be 2 times 3, which is 6. But if we go back and check our original problem, we needed a plus 7. We only have a plus 6. So we're going to see what the difference is between what we have and what we need, and we're going to write that as a remainder. So multiplying the two things we got, x plus 2 and 2x plus 3, gave us 6 that we had in our lower right box. But in our trinomial here, let me erase this so you can see again. In our trinomial, we had 7. So we're going to take the 7 that we have here and take away the 6 that we got through division. So think about that as being like in our warm-up, where we had 37 and we took away the 36 that we got by 3 times 12. So this is what we had from our original number. We took away what we got by multiplying our thing that we came up with, and we were left with 1. So we're subtracting this 7 we started with minus the 6 that we got from our math, and we end up with a remainder of 1. So we'll put R1 like we did in the warm-up. You could also express that, so this is 2x plus 3 with a remainder of 1. Probably a better way of writing that is 2x plus 3, and then we're left with 1 over whatever we were dividing by, x plus 2. So this would be how we would look at our answer. So 2x plus 3 plus 1 over x plus 2. So that's going to be very similar again to what we did up here, where we had 23 was our quotient, so that's the solution we came up with, but we had 1 out of 12 left, so we took our remainder and put it over the divisor as what was left over. Okay, so I know that's a little bit more with that one since it has a remainder going on, but see if you can do number 7. It'll work very similarly to this one, except that it's only a binomial and a monomial, so it's a little bit different for the boxes. I'll go ahead and draw those with you. So we're dividing by 7x, and we're going to be only having 2 boxes here. So try to fill those in and get your quotient and your remainder, and then check it with me by unpausing. Okay, so here we started at the top left. We're still doing that, even though there's only 1 row. We're starting at the top left with our 14x. And this is similar to how when we did the long division earlier, we started from left to right as we divided. We worked our ways from the hundreds place down to the tens, down to the ones. We're also working our way down from x squared to x to constants. So up here we must have had a 2, and then Oh yeah, and then we have no constant term. So basically, we had 7x times 2 makes 14x. But then this 8 is just extra. We can't multiply anything else here because it'll have x's with it. We can't make just a constant if the only divisor is 7x. So we're going to write our answer as the quotient is 2, plus we're going to do 8 minus the nothing that we have here. We had no constants. So we have a remainder of 8 over 7x. So this 8 was all extra. We didn't need any of it in the math that we did. All right, for number 8, we're going to rewrite that one. We're not going to do what it says there because it's the same repeated from number 7. We don't want to do the exact same problem again. So replace number 8 with this one in your notes. And let's do number 8 together, then I'll let you try 9, 10, and 11 on your own. If you're feeling confident and want to go ahead and do this one on your own, feel free. You can pause the video, and then I'll go over 8, 9, 10, and 11. Otherwise, let's go through this one together. So we're going to have an x and a 7 over here. Then we're going to have our box, or our area model. In our top left box, we need x cubed. To get x cubed, we must be multiplying by x squared, which means this box here would be 7x squared. We need a total of 11x squared. So in this next box here, we need 4 more x squareds. And to get that, we must have multiplied this x by 4x. Now going to the next box, we have 4x times 7 is 28x. And we needed a total of 27x. So now we have one too many, meaning our next box must be minus 1x. If this is minus 1x, our multiplier up here must have been negative 1. So negative 1 times x gives us negative x. So our constant down here, negative 1 times 7, is going to be negative 7. Now our constant is as far as we can go, because we can't go to another box here because it would have x's with it. So whether we get to the right number or whether we have a remainder, this is it. This is the last box we can make. Once you're down to no x term, you're finished. That's like your ones place when you're doing long division. So here we have negative 7, and we wanted negative 7, so that's perfect. This divided evenly, and our quotient is x squared plus 4x minus 1. That would be our answer. All right, try number 9, 10, and 11 if you haven't already. Pause the video and work those out, and then unpause it. I'm going to go through them a bit faster since these are ones I want you to do on your own. Hopefully you're figuring your way through it and just verifying that you're doing it with my video. Okay, so we're going to do this one with our divisor of x and 5. To make our 3x squared term, we need 3x, which gives us 15x here. We needed a total of no x's, so we're going to do minus 15x here, which gives us minus 15 up here. Negative 15 times 5 gives us negative 75. So here we had 4, but our math says we should have had negative 75. So our quotient is our 3x minus 15, but then our remainder is 4 minus negative 75, which is 79. So plus 79 over the thing we divided by, x plus 5. So that is our remainder term. So number 10, we have x plus 2 is our divisor. And then we have x squared as our first term, which means we have x in our quotient. The x times 2 would give us 2x here. And then that means we need 0 x's again, so we only have an x squared and a constant. So we need to cancel those with negative 2x, meaning that up here must be a negative 2. Our constant comes out to be negative 4. We compare that with what we have, and they match. So our answer is only x minus 2 with no remainder. It divides evenly. And then this 11, we have a 2x and a minus 5. Start off with 4x squared. So that would be 2x times 2x. Down here we'll have a minus 10x. A total, we need negative 24x. So in addition to this negative 10, we need another negative 14x to get to negative 24. If we divide negative 14x by 2x, we'll come up with negative 7. Negative 7 times negative 5 is 35. That divides evenly, so we have no remainder. So our answer is just 2x minus 7. Then we get down to word problems. The area of a flower garden is this trinomial. If the length is given by this binomial, what is the width? So I always think it's a good idea to draw any shapes that are described by a problem. We typically write the area inside the shape. So this is x squared minus 25x plus 150. The length, so we talked about this is width from left to right, so length here would be x minus 15, and we don't know the width. So we need to find the width by division because the area of the rectangle is the length times the width, meaning we need to find w, we need to divide the area by the length. So this one over that one. So let's go ahead and do that the same way we've been doing. The thing we're dividing by, the divisor, is x minus 15. And then we have our first term is x squared, meaning there's an x up here, meaning this is negative 15x. Since that is negative 15x and we need negative 25x in our answer, we're going to put negative 10x here, which gives us negative 10 up here. Negative 10 and negative 15 is positive 150. So that's our final box because we have no more x things. And we compare 150, 150. Perfect. That means this divided evenly. So our width is x minus 10. And if you want to be complete, we could give units. They actually don't give us units. But if they gave us units, we could put something like x minus 10 meters if it was in meters or feet or whatever units. Okay, so that's a word problem. Try number 13, this other word problem on your own. Make sure you have an idea how to do it, and then unpause and I'll go through it real quick. All right, so we should have drawn another picture. I assume these are rectangular, since most picture frames are rectangular. It doesn't say so, but let's make an assumption. We have an area of x squared plus 11x plus 28, and the width is x plus 4. We want to know the length, which, just like above, we're going to divide those two. So we have x and 4 here. We have x squared here, giving us x up here, 4x here. We need 11x, so that's 7 more. That gives us 7 there and 28 here. That 28 matches with the 28 that we had in the problem, meaning that we divided evenly and we have x plus 7 is the length of our frame. And again, if they gave us units, we could specify that as inches or centimeters or whatever it might be. Our homework for today is just more practice of this same stuff, just 8 problems where you're going to be drawing your area model, and then you're going to be finding what is the quotient, and if there is a remainder, what is that remainder. So go ahead and practice those. The key will be on Canvas for you to check it later. Okay, so that's all for today. Just finish up these practice.